Okay, so the theme of my presentation today is to answer the question, will 5G make IoT mainstream? And when I thought about this question, I thought, okay, interesting question. On the other hand, at the moment, we think IoT is already mainstream. So it's definitely not a niche market anymore. Wherever you walk in the world, you see IoT devices, or very often you don't see them. They are there, whether they are connected cameras or whether your car connects, or when you get in an elevator, there's an IoT system in there, or whether you use consumer devices such as an e-reader. These IoT devices are already around everywhere, also smart electricity meters in your home, but you may not notice it. On the other hand, 5G will add incredibly much to it. So I think the answer to that question, but I will go into more detail in the presentation, is IoT is already mainstream, and 5G is going to fuel and accelerate that even further. And 5G is going to open up a whole new world of possibilities and applications, which today cannot yet be addressed with IoT. So let's maybe start with where IoT stands today to underline my point that it is actually already mainstream. Just, of course, I have access to our internal numbers, and I'm sharing a few of them with you here. Vodafone already has 130 million IoT connections, so definitely not niche, and the growth is huge. We've actually doubled this number in the last 3 years. And also analysts expect that this growth continues over the next years. Also, the services are available everywhere in the world. I don't think there's a country where there are no IoT applications yet. Of course, some applications are more prominent in some countries than others, but overall, it's really a global business at the moment. And it has also reached already a certain maturity because we deal with only one SIM card, of course, one type of SIM, with all customers globally. So it's not that we have to deliver a German SIM to a German customer and a Spanish SIM to a Spanish customer. No, we give our customers who often produce in one factory their products in a certain part of the world, we give them one SIM card. And that we can even deal with difficult regulatory environments. For example, in Brazil, it's not allowed to permanently roam and have a SIM card from Europe in there, for example. We then transform this SIM over the air to a local Brazilian SIM card and support the customers there. But our customers do not need to put several SIMs into their devices, which makes the logistics difficult. And then we also have many networks and also 1,300 people deployed in the world already. So starting point to answer the question about 5G is a very strong one, a big one with a growing business. Also looking at the market, what have actually the applications traditionally been, and in order to make it very simple to explain what 5G adds, we actually simplified it very much. Now you may say, well, yeah, that's maybe a little bit too simple, that either IoT does remote tracking or remote monitoring, because there's also wireless credit card readers who send data, people download books. But with remote monitoring, we also mean if data is exchanged between a device and a cloud, that's all remote monitoring for us, but it's not a real-time control application. Yeah. So either today, actually 95% of all our devices today are either in trackers or in cars or in moving objects, or support data exchange from a device, a wireless credit card reader, or a remote maintenance device to a central station or to another device. That's today's world. It's not a real-time world. And it is not possible to do that with today's technologies. I will come to the characteristics of 5G on one of the next pages, but our systems today are actually, unfortunately, too slow to support true control applications, critical control applications, like, for example, autonomous driving or the remote monitoring and control of an electric nationwide grid network. Why? Because there you need absolute deterministic behavior, like a dedicated fixed line has. You need to be sure that if you press a button now, 3 milliseconds later in the remote location, something happens. And our networks today are very good for dealing with today's applications, but the control applications, autonomous driving, grid networks, remote operations on patients in hospitals and so on, they are super critical and they require an even stronger technology, and that's 5G. So when people talk about 5G, very often they limit themselves to basically the speed of download. Yes, you can download a video much faster with 5G than with 4G, but frankly, for video applications, if you have a good 4G networks, it's already a great experience today. 5G is a lot wider than that. Yes, it's much faster, and that helps with applications like, for example, artificial reality, gaming, augmented reality. There are also many industrial applications where people wear glasses and then it shows them real time when they, for example, maintain a complex engine of an airplane. It shows them real time what this part is, saves them a lot of time because previously they would have to look this up in very thick books. That's all helpful. And the speed is obviously one of the main benefits. On the other hand, latency, very important. Latency, the time it takes to get a message from point A to point B. On 4G, we can achieve 50 milliseconds, sometimes a little better, down to 30 milliseconds. Human reaction time is actually about 20 milliseconds. So if you drive in a car and you see in front of yourself, there's an object on the road or somebody's braking, actually, you need 20 milliseconds until you press the stop pedal and brake, the brake pedal and brake. So 20 milliseconds, so the human being is actually stronger in such an application today than an application on a 4G network. With 5G, that's a game changer. We can reach 1 millisecond, and that is much faster than a human being. So it's obvious that this then significantly improves road safety if automatic braking is done based on a 5G network. Today, the human is still faster than the 4G network. Furthermore, capacity is super important in IoT. We're seeing all these devices rolled out everywhere. Sensors, they're connected. And I think we've only seen the beginning of the amount of devices which will be connected. With current networks, we cannot connect as many objects in a certain area, like for example a square kilometer. With 5G, we can connect up to 1 million devices per square kilometer, which is a lot, but which we also believe will be necessary over time. And finally, reliability, being sure that the network is there, being sure that you have the capacity and get a message through, that is absolutely assured with 5G. We can reserve a slice of a network for a certain company, for example, for a certain application, and then nobody else uses this. It's like a dedicated fixed line, and that is very important for these control applications as well. So basically, with 5G, these characteristics make the network deterministic and suitable for control applications. I'm showing here on this picture a few control applications which are supported by 5G already today. A very exciting and new application is the one you see on the bottom right. The Ospedale San Raffaele is one of the largest hospitals in Milan, in Italy. And there, in the complex operation room, they have already installed a mixed reality where the system actually lets a specialist who can be remote supervise what's happening there and support the surgeon. Of course, there's still a surgeon in the room who is in charge with very complex situations. And that is super helpful because a few rare conditions at surgeries actually require specialists, and it's obvious that these specialists can't be at each place in the world at the same time. So this really is exciting and opens up completely new benefits for the people and for the efficiency of operations in general. Then we're also in the Midlands in the UK. On the top left, we're supporting a road infrastructure, connected road infrastructure, where objects recognize each other, do automatic braking, and so on. So that is all equipped with 5G, and that helps develop the ecosystem, which is also required to develop alongside autonomous driving to really have a safer and more comfortable traffic world in the future. Then on the bottom left, you see 5G drones for rescue missions, which is used by the Spanish Red Cross today already. And you send certain critical packages into dangerous areas with the help of drones. And these drones are supported by 5G because you need to remotely control them for longer than just the line of sight, which is possible today with drones. And there are already many such projects out in the world and growing at the moment. They all require 5G, and that's the exciting thing about it. So once more, looking at this from a related angle, we also in our mind we put IoT applications into different buckets. We say some IoT applications are optional for the device. What do I mean by optional? Basically, the maker of a device or the end customer can choose whether he or she wants to have the device connected or not, right? And good example are coffee machines. You can have them connected. It's more efficient then. The benefits are that the maker of the coffee machines know how their customers use the coffee machines. They can also do pay-per-use models and so on. But admittedly, there are also still a lot of non-connected coffee machines in the world, which also still make coffee. So IoT is helpful, but not absolutely essential for the business case to work, which in this case is making coffee. Then we have essential applications, like for example, people, you see that on the top picture here, people who rely on a system to give them vital parameters about themselves, about when they need to take their medication, or for example, the remote maintenance of production machines. We call this area essential because without IoT, that business case wouldn't work. You can't do remote maintenance of a machine without IoT. On the other hand, the difference to critical is the machine usually still works even if the connection is down. So on these essential use cases, it is helpful if the IoT system is super reliable. On the other hand, if there is some downtime or planned maintenance for 3 hours on a Saturday, you can deal with it and the production machines keep running. And then if something happens during that time, you just send the data later. It's not that a catastrophe happens when the system is down. And then we move into the critical applications where, if, for example, an autonomous bus drives with the help of the network, in the moment where the network is not there, the bus stops, and the whole application goes down. That is critical for us. Or in the case of a remote surgery, if the specialist, actually who knows exactly what's going on, is far away and the connection fails, then the whole thing doesn't work anymore. It gets really critical, and that's how we differentiate critical from essential. And for critical, we believe that we need the 5G network, which is deterministic and has all the characteristics that support that, as I outlined before. So alongside the performance technology, which we need for these control applications, we also need the performance support organization, because customers absolutely need to be sure that they have a partner who helps them set up these deterministic systems, and that if something ever goes wrong, there's a very strong support organization, and that you actually also further improve the processes and learn from the joint things that happen, and don't just resolve the problem and then things go on. So we're setting ourselves up for this deterministic partner of critical applications, which will be supported by 5G networks and where we will see more and more of these applications out in the world. In summary, coming back to the question in the beginning, will 5G make IoT mainstream? I've shown that from our point of view, IoT is already mainstream, but control applications, critical applications are not mainstream yet. That is what 5G changes. So 5G changes the paradigm and opens up the mission critical use cases. You need, however, a completely different mindset in an organization in the IoT provider than there is today. You need really critical systems, which have an uptime of up to 100%, and you need organizations which help the customers get their systems ready together with the IoT partner, and you need the very best customer support whenever something should go wrong. And then we actually believe that it's not that 5G will make IoT mainstream, it is actually that IoT will make 5G mainstream, because IoT is the area which will benefit most from 5G, in addition to possibly some other areas such as augmented reality, gaming, and virtual reality. So in summary, that's the presentation. And I would say we open up for questions now.
Well, Erik, thank you very much. And I must say the title of that session was a little mischievous, but anyway. I have a question for you, and which sector do you think is going to drive the largest demand for IoT over the next 10 years?
Yes, thanks, Annie. The sectors which are currently driving the strongest demand is the automotive sector, the healthcare sector, and the energy sectors. And we believe that's going to continue for a while. And on top of this come the new control applications, which I also outlined in the presentation. The critical applications also, when you look about the medical world, kind of moving from monitoring the condition of somebody to managing the condition of somebody in the medical world. That's where IoT will help. And also in electric applications, we move from the offline world. Smart metering, for example, is about reading how much you consumed in the last month, right? I mean, you can read that today or you can read that an hour later, no problem. But we are now also moving with IoT into grid monitoring, power control systems, where you actually monitor the electric network in real time, and where actually the management of the power stations and the output of the power stations is managed in real time, and that's also a game changer. So in these areas, we see the move from, as I showed before, essential applications to critical applications, which will drive a lot of growth in our view.
Thank you, Erik. We have a question from the floor. Thomas is asking, in your view, how do you see the future of NB IoT? Some analysts are saying that it has no future since it's more expensive than alternative technologies like Sigfox. What's your view on that?
I have a very different view on this, and we need to be precise when we look at the application. So Sigfox, for example, is a technology which is built for sending very short messages only. So the throughput through that network is by definition limited. It's a technology for sensors. We also have a competing technology called narrowband IoT for that segment, and there will be competition in that segment between Sigfox technology, LoRa technology, NB IoT technology, which operates in licensed spectrum, and so on and so forth. Then there are other applications, like, for example, autonomous driving, connected video cameras. There's more and more video analytics happening which absolutely requires a very fast, very reliable network. I don't see any alternative. I don't see even an alternative technology for this sort of applications. So in summary, the market will grow in all segments. Yeah, so there will be more sensors, and there will be more connected video cameras, and there will be more connected cars. Some of these growth opportunities can only be addressed with 5G networks, and some of them can also be addressed with other technologies, whether it's Sigfox, LoRa, Wi-Fi, Zigbee, Bluetooth, RFID, you name it. And in these segments, we, as the leading IoT provider, will also select the right technologies to have the right offering. Currently, that's NB-IoT in the area where you mentioned Sigfox. That's our approach.
Okay, so really it depends very much on the application.
Yes.
And IoT covers such an extraordinarily wide range, which
Absolutely.
brings us to our second question from the audience, which is, well, it's intriguing. Saeed says that IoT can support remote surgery, as invigilated exams, monitors shipping, production control, quality control, and so on. Do you think it will be used for observations in space and of other planets? And if so, how much do you think that will cost?
Okay, very good question. And actually, I don't know if you followed that last year, but or 2 years ago, we actually communicated that we are building a network on the moon, a mobile private network on the moon, which then collects data from the vehicles which are there and sends it back to the world, obviously through other technologies. I think the answer to that question lies in what you define as IoT communication, right? So of course there will be more and more space vehicles, or there are more and more space vehicles out there, even leaving our galaxy, sending data back to the world. Now, the data transmission, which they use to get the data back to Earth, is not what we define classically as an IoT network. It's not a 5G network. That's a terrestrial network. But connecting this to our networks is obviously something we've already done on the Moon project. But of course, that was also a proof of concept and an innovation project. So that's how I would answer that. It is not a classic IoT network, of course, if you send the data back from a different galaxy.
Okay, so slightly less out there, but still futuristic. We also have a question from Hatem, who says, do you think IoT will continue to improve with 6G?
In general,
I'm not sure we know what 6G is yet, but anyway.
Exactly, yeah, exactly. No, look, I think I answer that question just with the experience that I've personally been able to collect while going through the various versions of technologies. I already did IoT when there was still a 1G network, right? So 2G came before 2000, and then you had very little data throughput. And what I've seen is that actually with every new generation of technology, there come new use cases, and it supports new applications. So that's probably going to be the case as well. On the other hand, it's also a bit hard to imagine for me, because the possibilities with 5G are so ubiquitous that it's hard to imagine, you know, if basically you connect everything, if your cars drive automatically, if you, yeah, I gave the example of the human reaction time, you know, is there then a further benefit in latency of bringing it down to 0.1 milliseconds versus 1 millisecond? I don't know at this moment, but experience teaches that technology always evolves, and there will then be suitable applications for a new technology as well.
Okay. Very briefly, do you think private mobile networks will be a technology that drives 5G IoT adoption?
Absolutely. Yes, I believe that. And we're seeing that today in the market already. Because, the whole topic of Industry 4.0 or the connected factory, that's something where you require to have a very reliable 5G network directly in your factory, to which you then connect all kinds of devices, automatically guided vehicles, monitoring of all the sensors, which give you the state of the factory. And you need to connect all this data in order to see the health of it and the status, and then you can draw conclusions and always further improve it. That's happening today already, and 5G networks and mobile private networks will also play a critical role in it, because often such locations are in remote locations where there's no strong public network available, and then the mobile private network will obviously ensure the performance. Finally, on all these things, with 5G technology, we can also do a so-called slice for customers. So you can reserve a certain bandwidth of the 5G network for a customer, which is then similar to having a mobile private network in a location. But sometimes, like I said, in a remote location, the mobile private network is absolutely critical then.
Thank you very much indeed. That was a great start to our day.